Welcome to Bahamian Mathematics. Did you know that triangles are given different names based on the lengths of their sides and the sizes of their angles? In this video, we're going to learn how to classify triangles. We need to check the sides and the angles to determine what their names are. They will either be scalene, equilateral, or isosceles in this video. Let's look at the definition of a triangle. What is a triangle? Have you ever stopped to think about what the definition is of a triangle? Well, a triangle is a flat shape with 3 sides and 3 angles. Here's a triangle. This also is a triangle, even though it looks a little different. Here's a triangle. Well, this is a triangle. That too. That as well. But all of those look different. How do we determine the names of different triangles depending on how they are drawn? Let us have a look. Let's do activity 1. Let's try to draw a triangle in which each side is 10 centimeters long. So let's take our ruler and our pencil and let's draw sides of 10 centimeters. So here's one side, 10 centimeters. Let's move the ruler and draw another side, 10 centimeters. And the last side, 10 centimeters long. Each side now is 10 centimeters long. But let's see how big each angle is by using our protractor. Let's measure the first angle. Let's put the protractor on so that the middle of the protractor, the little crosshair, lines up with the vertex of the left angle in the triangle. And let's locate the 0 marking on the protractor, which is on the inside scale in this case. And we can see, if we extend the line, that the angle goes all the way around to 60 degrees. So here is 60 degrees. And now let's measure the second angle. We put the protractor again so that the crosshair is on the vertex of the angle. We locate the 0 marking on the protractor. In this case, it's on the outside scale. And we go all the way around. If we extend the line, we can see that it ends up at 60 degrees again. So this angle is 60 degrees. Do you think the third angle is also 60 degrees? Let's use the protractor and have a look. Let's turn the protractor upside down, making sure that the little cross again is lined up with one of the rays that make up the triangle. And we're going to locate the 0 marking. Here it is on the inside scale. And we go all the way around. And we can see that is also 60 degrees. If we expand it out, we can see, yes, that is 60 degrees. So the third angle in this triangle is 60 degrees. And so let's look at the sides and the angles. The sides, they're all at the same length, 10 centimeters. The angles are also the same size, and they're all 60 degrees. When we have a triangle in which the sides are all the same length and the angles are all 60 degrees, this is called an equilateral triangle. Now let's see what happens if we move the triangle. What happens if we rotate it like this? Is it still an equilateral triangle? Yes, it is. The sides are all the same length and the angles are still 60 degrees. That did not change. But what happens if we make the triangle a little bigger? And we say all of the sides now are 15 centimeters instead of 10. Is this still an equilateral triangle? Yes, it is. The sides are still the same length. The angles are all still the same. They are all 60 degrees. And this is still an equilateral triangle. The sides are the same, the angles are the same. Now let's do activity number 2. Let's draw another triangle. This time we're going to make 2 sides 10 centimeters instead of all 3. So let's take our ruler again, take the pencil, we're going to draw 10 centimeters. We take the ruler and move it onto the other side, we're going to draw 10 centimeters. And now we're going to connect the last side, which looks like 6.5 centimeters. And now we're going to measure the angles to see exactly what happens now when we have 2 sides that are the same instead of 3. What are the sizes now of the angles? Let's look at the leftmost angle. We line up the protractor properly. We find the scale that has 0. And we go all the way around to see where it stops. And in this case, we see it stops at 70. And so this angle is 70 degrees. Now let's measure the second angle. Let's put the protractor on the angle at the right. We locate the 0 marking. That's on the outside scale. And we extend the line and we go all the way around and we see again, this is also 70 degrees. So we mark that angle 70 degrees. Now just by looking at it, do you think the third angle is also 70 degrees? It looks smaller than the rest, but let's double check. Let's put the protractor on and check for ourselves. We locate the 0, we go all the way around, and we see it is not 70 degrees, it actually is 40 degrees. And so we mark this angle 40 degrees. We can see that two angles are the same. They're both 70, and the third angle is 40 degrees. And so what kind of triangle is this called, where we have two sides that are the same length and two angles that are the same size? Two sides are equal. They are both 10 centimeters long. The third side is shorter, it's 6.5 centimeters long. What about the angles? We have two equal angles, they're both 70 degrees, but the third one is 40 degrees. That's different. And so this is called an isosceles triangle, when we have a triangle with two equal sides and two equal angles. Isosceles. Are there any more names of triangles? Well, let's do activity 3 just to be sure. We're going to draw a triangle now with all sides different lengths. And so let's start with this side. We're going to draw a line, and that's 15 centimeters. Now let's draw the second side, and that one is 7 centimeters. And if we connect these two and we measure it, we see that's 14 centimeters. So they're all different sizes, they're all different lengths. Now let's measure the angles. If we line up the protractor on the first angle, we locate the 0, we extend the line just to be sure, and we go all the way around. We can see that it's greater than 50 degrees, but almost 55 degrees. If we look carefully, we can see that it is 53 degrees. Now let's check the second angle. We put the protractor on the second angle at the right. We find the 0 marking. It's on the outside scale. We can see that it goes all the way around past 20, not quite to 25. And so it looks like about 23 degrees. So we mark this angle 23 degrees. Now let's check the third angle. We line the protractor up. We find 0. And we go all the way around. We see that it is between 100 and 110. And it's almost at the midpoint, 105. And it looks like it's about 104 degrees. And so we can see we have three sides. They're all different lengths. And three angles, all different sizes. Let's check the sides. None of them are equal. They're all different. Let's check the angles. We have 53, 104, and 23. None of them are the same either. So no equal angles. When we have a triangle that has no equal sides and no equal angles, we call this a scalene triangle. So can you classify these types of triangles? Which one of the categories does it belong to? Is it an equilateral triangle, an isosceles triangle, or a scalene triangle? If we look at the sides, we can see that there are two sides of length 5 kilometers. If we check the angles, we can see that there are two angles that are 76 degrees each. And so we have two equal angles. Two equal sides and two equal angles, we call this type of triangle an isosceles triangle. Let's try another one. In this diagram, let's look at the sides. We have 10 feet, 8.5 feet, and 6 feet. None of them are equal, and so no equal sides. Let's check the angles. 29 degrees, 73 degrees, 79 degrees. All of those are different, so we have no equal angles. When the triangle has no equal sides and no equal angles, we call that a scalene triangle. What about this one? Let's check the sides again. We can see that 1, 2, 3 sides are 0.5 millimeters, so we have three equal sides. And we check the angles, we can see that we have 1, 2, 3 angles of 60 degrees, so we have three equal angles of 60 degrees. The first triangle we learned had three equal sides and three equal angles, and we called that equilateral. And now it's quiz time. What kind of triangle is shown? You have 5 seconds to give your answer. Time's up. The answer is two equal sides, two equal angles. That's known as an isosceles triangle. Question 2. What kind of triangle is shown? Time's up. We see three equal angles of 60 degrees. And even though we don't see the markings on two of the sides, Because we know each one of the angles is 60 degrees, it means that automatically every one of the sides has to be the same length as well. And so we can see the side MN is 10 centimeters, and therefore all of the sides are 10 centimeters. This is then an equilateral triangle. Question 3. What kind of triangle is shown? Time's up. We can see that there are no equal sides, 10 centimeters, 5 centimeters, 8 centimeters, and no equal angles. In this case, this is a scalene triangle. Question 4. What kind of triangle is shown? Time's up. We can see that there are two equal angles of 55 degrees. And the sides, we can see the markings with the two lines that show us that those two sides are equal. And therefore this is an isosceles triangle. Last question. What kind of triangle is shown? Time's up. We can see each side is a different length, 15, 34, and 32. And automatically we will know that each one of the angles is also different. So there are no equal sides and no equal angles. We call this a scalene triangle. And now you've solved the mystery of classifying triangles. Well done.